Good afternoon, guys. I hope everything is going well. Module 7 is what we're going to look at now. Just a brief overview. I'm not going to go into detail as usual, but I am going to kind of hit the high points and maybe point out some things that will probably be on the quiz. So let's go ahead and look at Module 7 and see what we have. All right, so here we are, Module 7, the objectives, explain types of abstraction in the design of physical network, describe and explain virtualization technologies on a network, summarize cloud characteristics, models, and connectivity options, and then identify methods to increase network availability. These are the things that we're going to look at. You need to know the difference between a managed and an unmanaged switch. You need to know the layers involved with each. An unmanaged switch is strictly layer 2. Managed switches can reach up into layer 3 and layer 4. And a managed switch basically has a command line that you can, or a web-based management utility that you can set some settings in and make it act sort of like a router, but not really. Redundancy, you need to know what that is. It allows for multiple paths for network packets to travel from source to destination, and it allows your network to be less vulnerable because there are multiple paths, so if one breaks, there are still other ways for you to get your information where it needs to go. However, you can end up with traffic loops, which means your traffic ends up in an infinite loop and it can't get out of it, so you can lose information that way. So you need to know the pros and cons of redundancy. These are diagrams, different outlines or different designs for networks. You need to know the different designs. You need to know these vocabulary words. There's a ton of vocabulary. Also, you need to know that for security's sake, you want to disable any unused ports. If you've got a switch that has things that aren't plugged into it, whether they be physical or virtual ports, you need to disable those. You can do that in a managed switch using either a command line for Cisco and things like that. Also, other switches have web-based. You can just go to the switch's IP address and it'll open up an HTML-based management application. You can do that there. So also you need to know what MAC filtering is and what MAC flooding is. You need to know what a load balancer is, and you need to know the different hierarchical designs. You need to know what three-tiered architecture is, the different layers, the different kinds of switches that are used in those. You need to know the difference between east-west traffic, which is traffic among peers, and north-south traffic, which is traffic, say, from a server to a peer. So traffic that is amongst peers, like one computer to another, that's east-west traffic. It doesn't matter what direction, really, that it's going. It's all considered east-west traffic because it's in a horizontal plane. And traffic that's in a vertical plane is called north-south traffic. You need to know three-tiered architecture, the core, distribution, and access layers. Essentially, you need to know spine leaf architecture, and you need to know the advantages that it provides. And software network as a service. Software-defined networking is using a software application to control all aspects of a network's virtual and physical devices. You need to know these vocabulary words. Oh, excuse me. Also, this is the difference. Forgive me. Also, you need to be aware. Also, you need to be aware of the different way that these networks are organized. You need to know what a SAN is. A SAN is a storage area network. Essentially, what that means is it's a collection of hard drives in an application or in a device. It's like a drive cage with a minimal operating system. And what it does is it allows you to connect a large bank of hard drives to a network and partition them as you can partition them as a RAID 5 or RAID 0, whatever you want to do. That also allows you to set it up as a single mapped network drive. So if you have a SAN, that's a storage area network, and that allows you to have drives for a file server on the internet without having to have a server. Basically, they're just storage drives, and they make network data available but they're just a minimal operating system, so you have to map to them with your computer like you'd map to an external drive. You really need a fiber backbone running to a SAN because especially if you have a lot of data there, it takes a while. And if you're getting a lot of requests, you're getting multiple requests from a lot of different nodes, then you're going to find that you have a bog in your network is going to really bog down right there. So you need to know the different types of connectivity that you can have. Another design for a storage area network. What SAN connection technology can run over ordinary networks? And that would be iSCSI. SATA requires a SATA cable, IB, and that was, I forget what it's called, it's InfiniBand. You have to have specialized connections, also FC, you have to have it, but iSCSI will use regular network cable. So what that stands for is small computer serial interface. That is something that you can use with a regular network. Virtualization. Now we get to virtualization. You need to know the difference between the host and the guest computer. You need to know what a hypervisor is. And there are two different types. One is installed in the BIOS, basically, the bare metal hypervisor. Before the operating system ever goes on, that hypervisor is available. The other type is a part of the operating system or is installed into the operating system. It's called a hosted hypervisor. Know the difference. And there's a diagram of the difference, and really the only difference is the host operating system is involved here, whereas type 1, this is just bare metal in the BIOS. You can manage a virtual machine using the hypervisor. Basically, it allows you to set up virtualization, build virtual machines. You can customize a virtual machine. You can install pretty much any OS you want to, except for Mac. You can designate an amount of memory, which is why anytime you're using a computer as a virtual host, it needs to have a lot of resources because you're going to be cutting up. It still has to have enough resources, enough RAM and space to run the host operating system. And then you've got a guest operating system running inside of that. So you need to have a lot of resources. You need to have a big enough hard drive to do all the things you need to do, and you need to have a processor that is probably multi-core VM capable, and that will give you a good efficient virtual machine. A virtual NIC is the network card that hooks to a virtual machine. Essentially what you've got is a host machine. That's the physical computer. Inside that, you're virtualizing a computer. You're building another computer inside that. It's got its own network connection, and basically it operates in the data link layer. That's how it connects to the host machine. Acts as a router or a switch. Basically, you've got the virtual machine talking to the network through the host machine, but the virtual machine gets its own IP address and its own information. Each virtual machine can have several NICs, several network cards. Generally, that maximum number is based on the whatever virtualization system you're using. And that's kind of what it looks like, but this is virtual. This is not real. So inside the host machine, you might only have one or two network cards, but inside that you can configure multiple ports in a virtual switch and then have multiple virtual machines hooked inside in a virtual network inside your host machine. And then that whole network could be hooked through one physical network port on your host machine to your physical network. Hope that made sense. You need to know the difference between bridge mode and NAT mode. Basically, you have the virtual NIC accesses physical network using the host's machine's NIC. That's basically what I said. It gets its own IP address, etc. In NAT mode, the host machine acts as a network area translation device. So it uses the IP address from the host and it uses the network resources from the host. And there's diagrams that designate that. Host-only mode, you need to know what that is. It's you know the vocabulary words for that. Once again, we got diagrams of virtual networks inside a computer. Pros and cons of virtualization. Pros are you don't have to buy computers. You don't have to buy expensive servers. It's an efficient use of resources. It really saves on hardware costs and electric bill. It also allows you to isolate, especially threat isolation, because you can, in a virtual machine, you can shut the whole thing down instantly and just disconnect it, and even set it to automatically disconnect if it detects some kind of suspicious behavior going on. Also, it's really easy to do backups, recovery, and replication because you're you're just running a computer program, so you can set automated tasks to do those inside the host machine. Disadvantage is it tends to slow down the host machine. You've got to figure you're using the same RAM and drive and processor. Instead of just running one computer, you're running multiple, can be 3 or 4. It also increased complexity. You have to know what you're doing to set up virtual machines and virtual networks inside the host machine. Also, licensing, you still have to pay for the operating systems that you install, so it's not saving any money there. And then this is probably the worst disadvantage. There's a single point of failure. If you're virtualizing your, say, your DNS server or whatever, and you have that running inside another computer and that computer goes down, then your DNS server is now down as well. So you can see how a single point of failure is never a good thing. Network functions is networking, virtualizing a network. Basically, you're virtualizing your firewall or your router. And so this is internally. You've got an inexpensive box laying around. You can install Cisco operating system as a virtual machine inside that box, and it will save you from having to buy an expensive Cisco system. Same thing with the router. You can buy a virtual machine, or you can install virtual router software to a virtual machine instead of buying an expensive hardware router. Advantages, well, mainly is saving money and resources, but the disadvantages we just talked about. Mainly it is a single point of failure and also reduced resources or reduced performance. You need to know what the cloud is. When people talk about cloud computing, on-demand services, broadband network access, resource pooling, you need to know what cloud advantages are. Some disadvantages, you need to be aware of those as well. On premises, that means all your cloud is on your building, managed at your site. On the other hand, infrastructure as a service, anything that you see as a service, that means it's virtual. That means it's actually somewhere else. So IaaS, infrastructure as a service, the hardware, the server, the drives, network infrastructure, all that is located somewhere off-site, and you're accessing it through the internet. Platform as a service, the operating system, runtime libraries, things like that, where your servers, these are off-site. That means you're using a platform as a service. Or you're accessing a virtual machine in the cloud. You're using the cloud to build, say, a Linux server if you need that, if you need Apache as a server. So you're accessing that through the internet rather than having the box on premise. Software as a service. Instead of having whatever software you're using, like say, I don't know, Microsoft Word, that's pretty much installed on everybody's computer. But if you were hitting a virtual machine in the cloud using Microsoft Word there, that would be software as a service. And then pretty much nowadays anything can be a service. There can be combinations of functions. Now the beauty of this, the distinct advantage to cloud services is you only pay for the things that you're using. If you build a database, if you build a SQL database in the cloud and you only get a tiny little speck of traffic, then your bill is going to be very low. And so each month your bill is based on how much bandwidth and how much of those resources you use, rather than just buying, okay, if I buy a copy of SQL Server, it's going to be very expensive. But if I set it up in the cloud, I can save a lot of money because I'm only going to get billed for what I use. So this is the advantage of the cloud as a computing resource. Public cloud, that means the cloud's accessed over public transmission lines. Private, that means it's in-site, that means it's in-house, your own servers, your own data center. Community cloud, that means you may have partnered with some other organizations to build basically what it amounts to is a private cloud that multiple people are using. It's not really a public cloud because you're not going straight over the internet, but it is not private either because multiple companies are using it. Hybrid cloud is a combination of the different services we looked at earlier, and a multi-cloud, basically a combination of other services in a single deployment. Your book will explain more about what those things mean. Infrastructure as code. Basically, I'll let you read that part. You convert more of your cloud maintenance security tasks into code that can be run from scripts. You're automating tasks. Connectivity and security. Now, here's some problems with cloud computing. First of all and foremost, ISP outages. When your internet goes down, your whole business goes down. You can see the problem there. ISP imposed bandwidth. Some ISPs give you a bandwidth quota for the month, and then after that, they start throttling you. So your internet for the first 2 weeks may work really well, really fast and lots of bandwidth, but after the first 2 weeks, say you've been really busy those first 2 weeks, then they start pulling back on the throttle and slowing you down, and pretty soon it's taking 20 minutes to download a single picture file. So then you can see it feels like you're on a dial-up modem or something. So you can see how that's a problem. Same thing with cloud providers. They can also, if your cloud provider, if AWS, Amazon Web Services, or Azure from Microsoft or whatever goes down, then you're down. And misconfiguration, this is bad, because what happens is if you don't set up your security correctly, then inside the cloud, somebody else could look at your data, and that's always that's a lawsuit waiting to happen. Unauthorized access to the data to the cloud by the cloud provider or hackers, either one. Breaches of confidentiality, all these things are related, and failure to comply with data security regulations, all those things are related. All of those things are potential problems for using cloud computing. Do the good outweigh the bad? That's a good question. Ways to reduce the risk: use encryption. Basically, carefully choose the method that you connect to your cloud resources. Consider the following. Virtual private networking is good. Basically, what you're doing is building a tunnel so you're not going through any other services. Having a leased line, that's an expensive prospect, but it can be done. A dedicated direct connection and a leased line are very similar to each other. Basically, what it amounts to is you're setting up a T1 data line directly to your ISP, your upstream provider, and that line, no one else can access the ISP through that line but you. So you have a dedicated direct connection to the internet, which is nice, but the problem is it's very expensive. Availability, you need to know what that is. It's basically how consistently and reliably a file or system can be accessed. High availability is what you want. Uptime, you want that to be around 99.999%. That's important, and it also tells you how to find uptime. So you can use Task Manager in Windows, or in Linux, you just type uptime in a command prompt. Fault tolerance, the capacity for a system to continue performing despite things happening. Redundant network cards, redundant power supplies, redundant hard drives. Hard drives that are set up as RAID 5, so basically you can make them hot swappable. You can pull out a dead drive, put in a new one, and not lose any data because the backup happens automatically or the restore happens automatically. These things add fault tolerance. Failure is when something doesn't work, and fault is a malfunction of one system component. Basically, I can have a faulty drive or a faulty power supply, those kind of things. And a fault can result in failure. I'll let you figure that one out. All right, MTBF and MTTR, you probably won't hear those in real life, but anyway, you need to know them for the test. To help protect against fault, networks often are designed with two or more of the same service or item. That is redundancy in a nutshell. You have multiple paths or multiple pieces of hardware. Automatic failover means that when, let's say, your power supply and your server dies, the redundant power supply right next to it picks up automatically, and there's no loss of trouble. Hot swappable, these are drives that you can pull out and put in. If your computer is set up with a RAID 5, basically what can happen is you pull the old drive out, you put the new drive in, the data is automatically restored, and so now you have basically no lost data, no lost time. Having hot spares, that's you've got it plugged in already, so then the hot swappable happens, and that new drive just takes off. Cold spare, you still have to install it physically, but then it takes over from there. Link aggregation, I'll let you read that. Load balancing, I'll let you read that, but it's very important. And there's a diagram of fault tolerance, different situations that can happen. And I'll let you figure out what CARP means in LACP. Basically, distributed switches or virtualized switches, which is no longer a reliable device. MTBF, that is not a metric that we use to measure anymore. All right, and once we've got all the information that we need, then these four goals are what we've hopefully reached. Explain the types of abstraction in the design of physical network, and that's the spine and leaf and the different types of network architecture. Describe virtualization technologies. Basically, we're talking about hypervisors. We're talking about the different applications you can install. Summarize cloud characteristics. We got networking as a service, software as a service, all those different things. Connectivity options. You can go over public lines. You can have a designated line. You can have a hybrid cloud. Those different types of clouds you need to be aware of. And then identify methods to increase network availability. And there's where you want to talk about fault tolerance and link aggregation. So, all right, guys. That is Module 7 in a nutshell. I didn't go too deeply into what each topic was, but I did try to point out the things that you're going to see on a quiz. And remember, if you have any questions, you can use the inbox or you can see me in class. Pretty much just about anything works if you'll just let me know. Make sure you let me know because I can't help you if I don't know. So if you have a question of any type, let me know, and I'll see you guys Thursday night.